Hey there! Today's question is, how does arrow pushing work? This is under the topic of organic chemistry. There's a lot of prerequisite knowledge you'll need to have in order to fully understand this concept, and we're going to go over them, such as valence electrons, electronegativity, and dipoles, as well as something called Lewis acids and bases, which we'll quickly go over. And you need this in order to really understand arrow pushing. So one of the more basic concepts that we need to go over is valence electrons. If you think of any element, such as oxygen, carbon, hydrogen, you'll know that each one has a specific number of valence electrons. Valence electrons are the electrons on the highest energy level, and they're the ones that do all the reacting. So we know that oxygen has 6 electrons, carbon has 4, and hydrogen has 1. And like I said before, these are the most important ones because they do all of the reacting. They are responsible for reactions. That's why you want to have a good idea of which elements have how many valence electrons. At this point in your studies, you should be familiar with the periodic table, but you just want to make sure you're confident in things like knowing periodic tendencies and just really knowing how to use this as your tool. So first of all, you'll want to know, of course, what a family is. So these vertical groups, these vertical columns, and then knowing what a period is. You need to know to differentiate between the two. And families are super important because when you look at them, you'll be able to tell how many valence electrons you have. That's how you use the periodic table as your tool. If you, for some reason, forget basically what element has how many valence electrons, you can just look at it and say, oh, wow, okay. Like right here, if you remove all the ones before these numbers, you'll see the number of valence electrons for each family. So if you look at the oxygen, you can see, okay, it's family 16, remove the 1, then you'll know it has 6 valence electrons. Periodic trends and tendencies are also super important to know because they tell you a lot of important information about atoms, such as size and electronegativity, which is a super important concept in organic chemistry. Electronegativity will tell you a lot when it comes to reactions. And so a quick trick to kind of be able to quickly compare electronegativity between atoms of the same period or family, you can just think, okay, same period, if you go from left to right, it'll be more electronegative. And if you go in the same family from bottom to top, the higher up, it's going to be more electronegative. Although it's not present on this one, some periodic tables will give you a numerical value for electronegativity, which makes comparison a lot easier. So electronegativity and dipoles are some of the most important concepts in organic chemistry. If we look at this molecule of water, we'll notice that the oxygen is a lot more electronegative than the hydrogen, and this creates a dipole. And so you'll have a region that is more electronegative and one that is more electron scarce. And a dipole is basically just an unequal sharing of electrons. So because oxygen is more electronegative, it grabs the electrons a lot more than hydrogen, creating a dipole, an unequal sharing of electrons. And this is a really important concept to understand. And so, as you can see here, around the oxygen, there's a lot of electrons, and it's more electron dense. And so Lewis acids and bases are kind of like the final puzzle piece here to kind of get here. And it's also super important, just like all the other concepts. And so here we're going to do a very basic intro to it because you can go really in depth into this, but for what you need, here it is. So it is just a different and more inclusive definition of acids and bases, and it focuses a lot more on electrons. So acids are known as electron acceptors, and bases are known as electron donors. So instead of focusing on the transfer of protons, here, electrons are the star of the show. They become the main focus. So now that all of these concepts have been covered, let's dive into arrow pushing. There are 3 major rules to kind of keep in mind when it comes to arrow pushing. It's that, first of all, you're visualizing the movement of electrons, not protons. You go from an electron-dense area to an electron-scarce area. And finally, you have to respect the octet rule at all times. There are different types of arrows, but the most common one is this one. It basically represents the movement of 2 electrons. You'll also come across a different type, which only has 1/2 of the area of the arrow, and it represents the movement of one electron, but you'll typically only use the first one in your first year course. So here's a pretty simple example that also has some practicality to it. So in water, we know there's many species like H2O, which is water, but there's also hydroxide and hydronium ions. So if we wanted to see the mechanism between how the molecules kind of transform from one to another, well, we could use everything we learned in this video to do it. So here I'm drawing two H2O molecules, and we can see, like we said earlier on in the video, that there's a dipole between the oxygen atoms and the hydrogen atoms. What this is telling you is that oxygen is the more electronegative atom in this molecule, which also means that around the oxygen is where there's going to be the most electron density. So now keep in mind that when you're drawing your arrow pushing, it always goes from an area of high electron density to an area of low electron density. So we already established that around the oxygen is where there's the most electron density, and around the hydrogen is where there's the least electron density. So you can transfer that lone pair to the hydrogen and make a bond. But there is one issue. This would break the octet rule. So how exactly do we work around this? The solution is actually a lot more simple than you'd think. Because you're making that extra bond with the hydrogen, it has to get rid of its other electrons. So what it's simply going to do is break its bond with the oxygen and give back the electrons within that bond. So there will be two electrons on that oxygen, giving it a negative formal charge. And then after this point, you're good. And you have two new molecules that I'll show in just a second. So now that you'll see that after these transfers of electrons, you'll end up with two new molecules, one being a hydronium ion and the other being a hydroxide ion. So now we've kind of gone over all the different species that exist in water. And that's essentially what arrow pushing is. It's the traveling of electrons from a high density area to a low density area. Now, here are some of the key takeaways from this video. Always consider the dipoles in the molecules. Remember the arrow pushing rules, and do as many practice problems as you can. When it comes to organic chemistry, practice does make perfect. Thank you so much for watching, and I hope this video helped you. Please consider leaving some feedback, as this is my first video and I really want to improve for you guys in the future. Also, please consider liking and subscribing. And remember, there are no stupid questions.